Hi class, this is Dr. Karsten, and this is a follow-up video to the earlier video that I posted for Lesson 10. In the other video, I really explored the concepts of Lesson 10 and how to use area model and division and factors to show the equivalence of two fractions. What we were really trying to do was to make larger fractional units. So I'm not going to go into all of that and all the concept development. If you have not watched that video, you must watch that video before you watch the problem set video that I'm currently making. So if you have not watched the other video, you need to turn this one off and go back and watch the other video first. So for this video, we are going to do parts of the problem set. So let's go and jump right into this first problem. So here it says, compose the shaded fraction into larger fractional units. Express the equivalent fractions in a number sentence using division. The first one has been done for you. So this first problem is actually going to be very similar to the problems that we were doing yesterday, where we were able to kind of regroup these or rename them into larger fractional groups. And we're going to be able to do that here again. It's not until problem 4 that we're really going to be using factors to try and find the greatest common factor. So for this problem, it should be pretty easy. You know what we're doing. And the first thing we want to do is we want to name the original fraction. So I'm going to set that up, and I'm going to take a look and see how many pieces make up the entire thing, or what is the total number of units in this model. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I know my denominator is 12, and that's the total number of pieces or the total number of units. So the numerator is going to be the number that is shaded. Remember, it represents what we have or what is shaded. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we have to kind of think, what are some ways that we could group this? How many pieces are going to be in each group? How many groups of can we make? So let's take a look here. And one thing that I'm definitely seeing is that I could do groups of 3. So this is similar to what we did yesterday, where we went ahead and we would circle groups of 3. Or we would circle the different columns, I should say. I have no remainders, I have no groups without, or no pieces without a group. I have groups that are either all shaded or all unshaded. So I've met all the requirements for making groups. And here what you can see is that I've made 1, 2, 3, 4 groups in total. So my new denominator is going to be 4. And that 1, 2, 3 of them are shaded. And I really went in depth in this earlier today, so if this is confusing, make sure you watch that other video. I'm just going to really quickly also redraw this for us, for those of you who maybe don't really see this. But now what we have going on is that we have 4 groups, 1, 2, 3, 4, and that 3 of them are shaded. So I'd have 1, 2, 3 shaded. And that's what we've done. In a sense, we've gotten rid of these lines. Now to do that, we can take a look and see, what did we divide by? How many pieces are in each of these? And what we have here is 1, 2, 3. So what we really are doing is dividing by 3. So I'm going to go ahead and start with my original fraction, 9 over 12, and show that we put them into groups of 3. So we divided them by 3. Now, again, what we did today earlier was we looked for common factors, and what I can tell you is that for 9 and 12, 3 is definitely a common factor of those two numbers. And just a quick reminder, the other thing you can do is you could look for all your factors of 9, 1 and 9, 2 doesn't work, 3 and 3. Once I get a double like that, I'm done. I've looped, I have all my factors. I could do it for 12 as well. 1 and 12, 2 and 6, 3 and 4, 4 is already here, so I've looped. So I'm done. And as you can see, 3 is a common factor for both of these. Okay, which is why we use 3. So Again, I did a lot of examples earlier today, so I am not going to do another one here in problem 1, but I am going to do for each of the other problems one example. So let's go ahead and let's take a look at problem 2. So in problem 2, it says compose the shaded fractions into larger fractional units. So we're going to divide again. Express the equivalent fractions in a number sentence using long division. Using division, not long division. So it's going to be the same sort of thing. Let's figure out what our original fraction is. So I have 1, 2, 3, 4, 5, 6 in total. So that's my denominator. My numerator is going to be the shaded ones, 1, 2, 3, 4. Let me set it up. So I'm starting with 4 over 6. We're dividing because we want to make our pieces bigger. And then I'm going to have my final. So again, I can easily see that a great way to group these is in groups of 2. So I'm going to go ahead and circle my groups of 2. 1, 2, 3. So I have groups of 2. There's 2 in each of my groups. So another way to say that is that I'm dividing by 2 over 2. Remember, whatever you divide the numerator by, you divide the denominator by, and vice versa. Whatever you divide the denominator by, you're going to divide your numerator by the same thing. So let's go ahead and write that 4 divided by 2 is 2, and that 6 divided by 2 is going to be 3, and let's see if that worked. So this would represent the number of pieces, the total number of units that I have, the number of total units. Here we go. 1, 2, 3, and this is the number that are shaded. 1, 2. So it worked. So you're going to be able to do B on your own. So now I'm going to really quickly go over problem 3 with you. So for problem 3, let's go ahead and do 3A together. So it says draw an area model to represent each number sentence below. So what I have to be able to represent is that I'm changing 4/10 into 2/5. So one thing that I'm noticing is that it would probably be a good idea to have 5 columns if I want to make my life easy. So I'm going to already plan for that I'm going to make 5 columns in my drawing. And then it would probably be a good idea to have 2 rows in each column. So I'm going to draw that. So if I go ahead and I draw this, making it nice and long, and I need to make 5 columns, doing my best to make them equal. Okay, they're not quite, but it's good. And then I'm going to go ahead and cut them in half. So now I have a total of 10 units in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I need to shade in 4 of those because that is in my numerator. So let me shade in 1, 2, 3, 4. So now what I need to do is I need to model dividing by 2 for both of those. And what I'm going to do is I'm going to circle groups of 2. So I'm going to circle 1, 2, 3, 4, 5. So let's see, I have 1, 2, 3, 4, 5 groups that I've made. So that matches my denominator. And 2 of my groups contain shaded regions, or all shaded. So I have 2/5. So we just modeled how to do this. Okay, so let's move on to problem 4. Now problem 4, I'm going to slow us down a little bit because this is where it gets to be really the new material that we were working on today. It says use division to rename each fraction given below. Draw a model if that helps you. See if you can use the largest common factor. And that was really what we were working on a lot today. I was trying to really help you to remember how to find all the factors and then to figure out what is the largest common factor. So I'm looking and my numerator is 4 and my denominator is 8. So if I want to find the largest common factor, I'm going to go ahead and do that over here. I'm going to slide it over a little so we have some more room to work in. So remember how I've taught you so that you don't miss any of your factors. We try 1. Does 1 work? Yes. 1 times 4. So those are factors of 4. Does 2 work? Yes, 2 times 2. I have a double. So I found all my factors of 4. Let's do the same exact thing for 8. So for 8, I'm going to again start with 1 times 8. Then I'm going to try 2 times 4, which I know works. I'm going to try 3, but 3 does not work. There's no way I can make 3 times another number equal 8. 4 works, but I've already written it, so I've looped around. Once you loop around, you know you have all your factors. And I'm going to go ahead and just write them out linearly in a row here, because it's easier for us then to find the common factors. So I'm just going around. So here for 8, I'm going to go 1, 2, 4, and 8. You want to put them in order. It'll help you. And now I'm going to circle the common factors they have. So 1 you'll always have, but 1 doesn't really change anything when we're dividing, so we're going to leave that one alone. Then we have 2 and we have 4. We want to find the largest common factor. Common means that they both have it. Largest would be the biggest number. So that's going to be 4. So that's what I'm going to use, is 4. So now I want to model that with a division sentence. I'm going to slide this over a little, make it more clear. Okay, so I'm going to start with 4 over 8. And then to show what I'm doing, I'm going to rewrite 4 over 8, and then I'm going to show that I'm dividing both of these by that 4, that factor that they have in common. When I divide 4 divided by 4, I get 1. 8 divided by 4 is 2. And so our answer is going to be 1/2. That is going to be the largest fractional unit that I can rename 4/8 as, because it has a 1 there, and it's also our largest common factor I use to divide. So we now know that we have the largest fractional unit for 4/8. We can turn it into halves. And if I wanted to really quickly, just to make that super clear for you guys, draw it. You do not have to do this. Draw a model if it helps you. So when I started out with 4/8, and I'm going to draw 2 separate models for this one just to make it super clear. Normally you wouldn't do that. You know that you would put your circles around this one. But I really want to make this clear for you guys. So that was 4/8. Now I'm going to model 1/2 so you can really see that these are equivalent fractions. But here I'm just renaming it or expressing it in the largest possible unit, fractional unit that I can. So you can see that of this, you can clearly see that half of it has been shaded in, and the same thing here in this model. Half of it's shaded in. These are equivalent fractions. Okay, so I'm going to do one more of these since this is really the new material, and then you'll be on your own to do the last 2. I'm going to have to work at finding room on here. So let's take a look at 12/16. So again, the place that I want to start is I want to start by finding my factors of 12 and 16. So just to make sure we don't get confused, I'm going to kind of mark that off. Let's find all our factors of 12. So 1 times 12 works. Does 2 work? Yes. 2 times 6. Does 3 work? Yes. 3 times 4. Does 4 work? Yes, but I already wrote it. I've looped. Now let's try 8. So I have 1 times 8. Oh, am I doing 8? No, I totally messed that up. I looked up here. I'm doing 16. So let me do it. I'm going to do it here just to make it have room over here for something else. So I'm going to have 1 times 16. Does 2 work? Yes. 2 times 8. Does 3 work? No. Does 4 work? Yes. 4 times 4. I have a double. I've looped. So I'm going to go ahead right here and write them linearly. So for 12, I had 1, 2, 3, 4, 6, and 12. And for 16, I had 1, 2, 4. You only have to write the double once, 8, and 16. So they have 1 in common, they have 2 in common, they have 4 in common, and I don't see anything else in common. Again, I'm going to be using 4 because that's the largest common factor, the largest factor that they have in common, that they share together. So let's go back over here and let's write out the number sentence. So I'm starting with 12 over 16, and then I want to show what I'm doing with it. So I have 12 over 16, and I'm going to divide both of them by the 4. That's their largest common factor. That will give me my largest fractional unit. And then if I divide 12 by 4, I get 3, and if I divide 16 by 4, I get 4. So 12/16 and 3/4 are equivalent fractions, and this is the largest fractional units that I can express 12/16 in. Remember, so I think that covers it. I slowed down for number 4 because that's really where things are getting different from our lesson yesterday. So if you have any questions, I will be in our Google Classroom. You can meet me there. We also have our meeting later today that we can meet up in. So if you have questions, let me know. Otherwise, I think that this was pretty clear. I will put a posting that this is up for you to take a look at. Again, make sure you watch the other video. It really went in depth, step by step, to make sure that you understood what we were doing. All right, so that's it for today. I will see you later in our Google Classroom. Have a great day.